So now that we know how to take equations and rearrange them into slope-intercept form, we are going to learn how we can use this form to help us make graphs. Right now, the only way we know how to make a graph is by making a table of values, which works all the time, and it's a great strategy to use. But there are some faster ways to make graphs depending on how the equations look. So you may have seen this before, y equals mx plus b. This is what's called slope-intercept form of an equation of a line. And in this equation, there are usually numbers. For example, y equals 3x plus 7. Now those numbers tell you special information about the graph. The first number, the 3, corresponds in the equation to where the m was located. This number is what we call the slope. We can think of the slope as how we move between points on a graph, which is why we usually write the m to stand for slope. Now, another way to think about slope is rise over run. So when we're looking at 3, for example, we would say that that's really 3 over 1. The second important number in this equation is the y-intercept, the number that corresponds to the b. The y-intercept, as we've seen before, is the place where the graph crosses the y-axis. We can also think about the y-intercept as where we begin our line. We think about the b as standing for begin. Now, when we want to graph a line, and this is really important, you have to start by rearranging the equation into slope-intercept form. In other words, you have to get y alone before you can start graphing. For example, if I said graph this equation, then off to the side, your first step would be to copy the equation and work on getting y by itself. Now, in order to get y by itself here, all I would have to do is subtract 3x on both sides. And when I do that, the 3x's cancel on the left, so I just get y. I'm going to write the term that has the x first. So I'm going to write the negative 3x first, and then the plus 2. After you've done that, you can easily identify your slope and your y-intercept. In this equation, the slope would be negative 3. And the y-intercept would be 2. We're going to start by graphing the y-intercept first, because the b tells me where to begin. So the y-intercept is always going to go on the y-axis, which is the vertical axis on the graph. The y-intercept has a positive 2, so we're going to start by putting a point on the location where y is 2. Now for slope, we're going to use the slope to move on the graph to make more points, because the m stands for move. So in order to do that, I need to see a number on the top and a number on the bottom. I need a rise and a run. I can always put over 1 underneath any number so that I can see the rise and the run. This says go down 3 and then right 1. Rise, run. So I would go down 3, 1, 2, 3, to the right 1. Go down 3, 1, 2, 3, to the right 1. And I'm going to put new points every time I do that. Now another option is always to go in reverse. So instead of going down 3 from where I started, I could go up 3. And then instead of going right 1, I could go left 1. So you reverse both of the directions here. Finally, I'm going to use a straight edge, and it's really important that you use a straight edge to make a nice straight line, to draw a nice straight line on my graph. A good example of a straight edge would be something like your ID or a bus pass or a credit card. Let's take a look at some more examples where we're going to practice this. So for problem number 1, it looks like the equation is already rearranged correctly for me. It already says y equals mx plus b. Based on that, I can tell that my slope should be negative 1 over 4, and my y-intercept should be 2. A lot of students ask, do I put the negative on the top or on the bottom? I would say I would always put it with the top number, but you cannot put it with both numbers. I cannot make the 1 negative and the 4. Just the top number becomes negative. Now the y-intercept tells me where to begin. So on the y-axis of the graph, I'm going to start on the positive 2. The slope tells me how to move. This slope says go down 1, right 4, or go up 1, left 4, and I could reverse both of the directions. Once I have ordered pairs like that on my graph, and I've graphed as many as possible, for example, I couldn't go down 1, right 4 again because I wouldn't have enough room, so I've done as many as I can that fit. Then I'm going to use my straight edge, which again, an ID or a bus pass or something like that would be a great option, and I'm just going to draw my nice straight line. For the next problem, the slope would be negative 2, and the y-intercept would be 5. I'm going to begin on the y-axis on the positive 5. Now, negative 2 is a great slope, but I can only see my rise. I can't see my run yet. So I'm going to put over 1 here to show that I'm going right 1 each time. So from this green dot, I'm going to go down 2, right 1, 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 until I run out of room. I could try to go backwards. I could go up 2, left 1, but you can see that I'm off the graph. So I'm good with just graphing what fits. Next, I'm going to take my straight edge and I'm going to connect the dots in a nice straight line. Now let's look at some additional problems. What makes number 3 different than the other 2 problems is that the equation is not already arranged correctly for us. So what we're going to do first here is rearrange this equation to get y by itself. Now what I would probably think I should do here is subtract the 2x on both sides in order to get y by itself. When I subtract the 2x, I'm going to have y equals, I'm going to bring down the negative 2x first because I know that I want the term with the x to be first, and then plus 3. Now from here, I can identify my slope, which is negative 2, and my y-intercept, which is positive 3. Now again, I need to see my rise and my run, so I'm just going to write negative 2 over 1 here so I can see both of those numbers. Now the 3 tells me where to begin on the y-axis, so I'm going to start by putting a dot on the positive 3, and then the slope tells me go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. I could also try going up 2, left 1, and one more point does fit there. Finally, I'm just going to connect the dots in a nice straight line using my straight edge, which could be like an ID or a bus pass or a credit card. Let's do one more example. So for problem number 4, we're going to start by rearranging this equation into slope-intercept form. I'm going to draw a vertical line. The first thing I think I'm going to probably do here is subtract x on both sides. So I'm going to have 3y equals negative x plus 9. Now I need to get y by itself, so I'm going to divide everything by 3. What makes this a little bit tricky is that we can't see the number that's by the x, so we need to remember to write in a little 1, so that would be like a negative 1 there. The y is now by itself, and I'm going to ask myself, does negative 1 divide nicely by 3? And the answer is no, so I would just write negative 1 over 3, and then put the x next to it. Then I would ask myself, does 9 divide nicely by 3? And the answer is yes, and you get 3. Based on that information, the slope of this line would be -1/3, and the y-intercept would be 3. So I'm going to start on the y-axis on the +3, and from there, my slope says go down 1, right 3. Down 1, right 3, or up 1, left 3, up 1, left 3. Then I'm going to use a straight edge to make a nice straight line through those points. All right, that's it. Thank you guys so much for watching. Have a wonderful afternoon.